The next speaker is Avishai Isakian, DGM Marketing, Business Development and Sales of Airborne Radar Systems, ELTA. Since February 2007, he serves as the DGM Airborne Division of ELTA. His current position is responsible for marketing, sales and business development of airborne systems of the radar division, which develops and manufactures airborne radar systems, AEW aircraft and special mission aircraft. Prior to this position, he was the program director for the development of CAEW system delivered to Israeli Air Force in 2008. He joined ELTA in 1990 as a chief system engineer for AEW&C system and later appointed as a program manager for the first ASA based AW system developed by ELTA for the foreign customer. He is married, 3 children, holds a BSc and an MBA degree. Now, for you, sir.
We are online. Sorry for the delay. Okay, this afternoon, I will discuss the trends in special mission aircraft. Maybe I will start with a short presentation about IAI, which is our mother company, Israel Aerospace Industries. IAI is a world-leading aerospace technology house and actually is involved in all areas of aerospace technology, including aircraft design and development. We actually design and develop several types of business jet. And actually, I will cover the second issue that IA is doing is intelligent sensor and system, which include the subject of special mission aircraft. As you can see, we are doing many other things, which some of them are being in operational use by the different Indian agencies. One of our key capability is derived from our huge investment in R&D. Last year, we invested almost $1 billion in R&D, which is about 1/4 of our scope of business. We are a global company. We cover all continents, and it's a medium-sized company if you look at the big American companies, with 6 main groups covering the different area of operation. I specifically coming from ELTA system, which was very nicely presented by my colleague from CAPS. We are delivering the AWACS to the Indian Air Force. Our sales of last year is around $4 billion. One of our key strengths is in complex system of system. And actually my presentation today will cover one aspect of the system of system, which is the special mission aircraft, which is actually an aircraft which holds multiple sensors working together, and we are providing our customer with an end-to-end operational approach. It means that we are providing a total solution that covers everything, starting with the airborne system, ground system, training, everything that is required for the customer to induct the system very quickly into operational use. A few examples that you may be familiar with our system of system. One is my colleague, Mr. Takarani from CABS, mentioned the AWACS. We have an air and missile defense system like the Barak 8. We have a very advanced naval weapon system. Again, one of them is the Barak 8 system. We have a spaceborne system. This is the TESCAR, which is a spaceborne SAR system. And we have the Heron TP, which is a very large UAV with a payload of over 1 ton. Actually, what is our place in the global market is mainly in providing cutting-edge technologies based on innovative and high performance. Now, these are very nice and very high-level words, but this is the way of our survival. I'm coming from a relatively small country, Israel. We have about 7 million people. And the way that we struggle through our actually existence in the Middle East and also in our place in the global market is by using technology and actually having the most capable system today in the market so that we have some kind of advantage, firstly, in our territory over our neighbors, and secondly, in some aspects, some advantage over our competitor. Now I will discuss the trends that we see as the industry in special mission aircraft. Again, there were several presentations both by users and by government. I will give you our perspective as industry, as the trends, and how we see the challenges that are involved in these trends. Actually, if you look at the legacy special mission aircraft, you see segregation by types of surveillance. Everybody knows the AEW, the MPA, AGS, and SIGINT, which is, as a legacy, have a very distinctive system. I use the American system just as an example, like the AWACS for the AEW, the P3 for the MPA, the J-stars for the AGS, and the rivet joint. We also, about 25 years ago, when we had our first special mission aircraft, we started with this concept, which is dedicated platform for each mission. But even so, if we take this system, it was actually the first sign of what we call multi-mission aircraft. This aircraft, which is a 707 base, was delivered, was become operational in South America in 1995, which makes us the first company to induct ASA-based AEW system in the world. Sub was about 2 years later, and we are trying to keep our leading edge in the market by actually developing several new generation of this ASA technology. Actually, I use the analogy to something that almost everybody have in his pocket, which is a cellular phone. Back in the 90s, where actually most of the example that I gave was 80s and 90s, we started with the phone that is only a phone. Today, we have much more. And if going to the analogy of the special mission, typically the AW, for example, was doing mainly air surveillance, to some extent maritime surveillance. And the MPA was doing anti-surface warfare, anti-submarine warfare, and some extent search and rescue mission. SIGINT was doing mainly SIGINT, and AGS was doing mainly ground surveillance. Today, what we see is that we have a very wide variety of missions, both for military and civilian and paramilitary. I think that I just note some of the things that, for example, anti-piracy, something that I know that the Indian Navy is very much involved and is trying to counter the anti-piracy in the Indian Ocean. And this actually gives new challenges to Navy rather than the fight against enemy Navy, which is coming from the legacy CONOPS, to where your enemy is a small boat, fast-going boat. It's not hostile in the sense that you can go very close to it and even take photos in order to in some cases, you may even use it at court. So actually, the challenges today is that you have so many missions, both for military and civil, and the same system should be used one day for military use and the other day for a civilian or paramilitary. So what do we see in the market? If we take the analogy of the cellular phone, The phone that was 20 years ago only a phone is now a multi-mission system. And this is probably Nokia will forgive me, because probably I forgot some of the missions that are somewhere embedded in this machine that I'm not aware of. But each of them is very capable. If I just take the most obvious one, the latest model have 12 megapixel, which is equivalent to one of the best cameras today in the market. So it's not just a very minor capability, but each of the capability here is a high-definition TV and a high-resolution camera, etc., etc. So actually, what is the idea? The idea that we have used for the last 25 years is to use codes, and by using codes, you can have the benefits of everything, all of the technologies, like computers, communication, etc., are becoming much more powerful. The performance is incrementally improved, while weight and size is decreased. So actually, what we can achieve by this is going to a smaller platform, which are much more affordable and cost-effective, and integrate much more system on the same platform, in the same time getting a steady improvement in the operational capabilities. And actually, I mentioned in one of the first slides, the 707 of the 90s, there is a huge jump, and we don't believe in evolution in the sense that if you look at technology, in order for us as IAI to survive in the market, in many cases we have to go into revolution. And actually, this is where we are trying to be in our AEW market. Each generation actually mean a totally new design, a very big leap forward in terms of weight and size, and the factor is 2, 3, and sometimes more reduction in size and increase in performance. So actually, what is the trend? The trend is actually multi-role, multi-mission configuration. We don't have the traditional division or the traditional division to system. Actually, there is some kind of mix between the different capabilities and mission, and this have to be supported by the right architecture and the technology and design that enable us to integrate the different capability on one aircraft to have the proper data fusion, the proper interoperability with other assets, all of this to achieve multi-role and multi-mission capability. And one of the challenges is that we have to integrate information from much more sensor. Each of the sensor is much more capable. It means that we get much more information, and the information is much more accurate than in the past. And the challenge is to fuse everything into one common picture. I will try to give example from our product of the three main areas that we are involved, but this is clearly not all of the special mission aircraft today available, but I will address these three. Actually, one that I already mentioned is the AEW, which is actually already multi-mission. If we have seen the presentation of my colleague from CAPS, it's a multi-role in the sense that it has a radar, IFF, ESM, CSM, and other sensor like AAS, IFF, etc., etc. But its traditional role is mainly air-to-air, and we have expanded this capability also to much more significant or substantial air-to-surface capabilities. So one derivative of this is what we call air and surface surveillance, which balance the air-to-air and air-to-surface capability. Another branch is mostly the surface surveillance. And again, in the sense, surface surveillance in many cases, as you will see, will have some air-to-air capability. But still, our primary focus would be on the, in this case, maritime or ground surveillance capability. Today, not like 20 years ago, the limiting factor is not technology. I think the technology is there, and as long as you use codes and especially in our case, because we are exercising a very short development cycle, something which is about half of the normal standard in our market. A normal development cycle for our aircraft is about 4 to 5 years, which enable us always to deliver a system with the most updated technologies on board. Actually, the limiting factor is the operational profile. For example, you would not use AEW&C, you will normally use in a high altitude profile, maritime patrol, especially for example, anti-piracy, you would have to go to lower profile. So actually the challenge is more operational rather than technology to integrate the mission. Some examples, I will cover example of the 3 main categories that I mentioned of this multi-mission configuration. I will start with the AEW&C program. As was mentioned, this is the Il-76 AWACS, and this is the G550 CEW. Both are 3rd generation AEW, and when I'm speaking again, 3rd generation, it means that we have started in the early 2000s with development of a totally new system suite for the AEW with a much more capable and lightweight ASA technology, and this is the basis for both systems. Actually, what we have done is by using the Il-76, we were able to provide our customer, the Indian Air Force, with a very extreme and a very high capable system by providing, as you say, as was mentioned, equal 360 coverage, but the Gulfstream actually have, in many aspects, very similar capability, and we were able to exercise all of the potential in this platform, which is a business jet. As you can see, it's a full suite of AEW that include actually 2 types of radar, S and L and S, which have a 360 4D coverage. We have an ESM, we have a SATCOM, we have multiple links, line of sight and beyond line of sight. And actually this platform provides naturally air surveillance, sea surveillance, and also ESM link capability. All are done concurrently, display automatically to the operator, and sent to the ground. Just a few examples. A typical air-to-surface surveillance would be detection of airborne assets and naval assets using all of the sensor like radar, IFF, or in the case of maritime, you also use the IS and ESM. ESM is also means for both detection and identification and classification. Actually, the bottom line is to generate an integrated situational awareness picture. It means that all of the information from the onboard and external sensor is being fused to a single picture, and the operator have all the information available, and the information is sent to the ground with broadband data links. And actually, in the NetworkCentric, and this platform is one of the first to exercise a very complete and very comprehensive NetworkCentric approach, is that we share information with all other assets, fighter, ground, naval, whatever. Going to the next step is we have included in the CEW an X-band surface multimode radar, which I will address in a few minutes. And this gives the aircraft with a true surveillance and imaging capabilities for surface targets. So actually, and also we added the electro-optics pod, which enabled this aircraft to use for maritime mission, and especially in what we call homeland security mission, for example, anti-piracy. And actually, if you look at the overall capability of this kind of platform, it's a very broad capability, starting with very extensive air surveillance capability, ground surveillance, and maritime surveillance. And all of this is achieved, again, by using information from different sensors. Each sensor have its own strengths, so by actually leveraging the capabilities of each sensor and integrating it, you can get a comprehensive picture and also response during flight. So in some cases, as I will show, you will have the initial detection in long range by, for example, the phaser radar. But when you can be close enough to the target, you can use, for example, ISAR for classification and further tracking of the target. This is a typical naval scenario. Start with standard generation of air situation picture, or in this case, maritime situation picture. Use the radar for a very long detection and surveillance of maritime assets. You use the AES, ESM, and in some cases IFF for completing the picture. If you get a little bit closer, especially if the target is not supposed to be dangerous, you will use the ISAR, which is inverse SAR or range signature, which enable you actually to classify the target. You will use the electro-optics to identify and in some cases to provide evidence if we are talking about some kind of civil operation. And in some case, you would even use the radar, the X-band radar, which is very accurate for tracking and guidance. Just one example, maybe I will show how do you use this configuration for law enforcement. Actually, you start with detecting of very small, low-flying aircraft. Then you monitor the rendezvous with your surface capability using SAR and later on GMTI. The SAR, for example, enable you to identify the airstrip, and the GMTI will enable you to track the aircraft on move or the vehicles. Then you go back, you can see continuously track the vehicles that are leaving the area by GMTI while tracking the aerial asset with your airborne capability. Another example is law enforcement in the maritime environment. You start with a very long detection of maritime assets. Then you use the ISAR or range signature for identification. Then you use you detect rendezvous with your capability to detect very low RCS maritime target. And all of this is monitored from the same platform with a very, very short cycle of action. The next example that I will give is a maritime multi-mission configuration. This is our Q400 Maritime that was proposed to several customers, including several Indian agencies. As you can see, it has a very comprehensive suite that addresses every possible mission environment. It starts with our multimode radar, which is here. It have clearly ESM and CSM and SATCOM and all of that can require communication. It have hard point for armament, fuel tanks to have a very, very long range. And actually it provides a complete solution with a commercial, and one of the strengths that we see in the special mission is using the commercial aircraft which actually can keep their civil certification. We just heard about FAR 25 certification. Actually, one of the key sensors that we have in this platform is the 2022 radar, which is very known to many, many customers, including the AEW&C. It's a multimode radar. Just one example of all the capabilities that this kind of radar have. It starts with very obvious sea and air search, combined with the capability of AES integration and IFF, of course. It has the weather, especially if you have a nose-mounted capability, ISAR and range signature, and all other capability there for both ground and maritime environment that makes him a true force multiplier for multi-role, multi-mission aircraft. The next example would be a ground and maritime configuration. This is based on a business jet. Again, the key sensor would be a SAR GMTI multimode radar. Again, all the capabilities of ESM, CSM, electro-optics, very extensive communication, command post, etc. The idea depends on the mission. Typically, search and rescue and anti-submarine warfare will require a turboprop, which is a low-flying, relatively slow. Although the Key 400 is a relatively business jet-like velocity, it goes to 360 knots, which making almost equivalent to jet aircraft. But if you are using a jet aircraft, you will have what we call long range, a very long range, and very high capability for both ground and maritime missions. Just a few examples. This is the Reconnaissance capability, which use SAR imaging, ESM, and CSM, and the surveillance, which enable us to have high-resolution SAR like spot SAR, in which you get much higher resolution, and GMTI, which is a ground-moving targeting detection. Here you see all the tracking of the movement, in this case, on the roads. What are the technical challenges, especially from the eyes of the industry, of multi-mission configuration? And actually, the first thing that we have used in the last decade is actually using all the advantages that we have in technology. Naturally, and this comes from our environment. Actually, in many cases, the Israeli Air Force is our launch customer, and he is requiring the most high performance available. But how do we achieve it? We use COTS, and very extensive use of COTS is beneficial, and we see the system that we have delivered 10 or 15 years ago that can be very easily upgradable. High-level software language. It means that we can easily include new system in new configuration, adapt our capability to user requirement. Open architecture. This is, again, easily a plug-and-play philosophy. It means that we can include, for example, any communication suite that our customer need with a relatively minimum effort and with a very, very modest cost. One of the key elements is what we call software-based system or software radar. Actually, in the same analogy of the phone that I mentioned a few minutes ago, a phone is actually a piece of metal that is running software. And this is actually, none of the function is done by hardware anymore. And this allows us to have a very lightweight, very capable system, and very easily adaptable to the user requirement. And naturally, as was mentioned, we are implementing the ASA technology for the last 25 years. We have this both in AW, we have this in fire control radar and other application, and this today for ELTA is a standard technology for most of the application. One of the key buzzwords that you will hear is IP-based architecture that I mentioned. And I use the use of the analogy of the USB that today you just plug the system. Unfortunately, it's not as easy as you see it in your laptop, but if you use an open and accessible and flexible architecture, you are able to provide your customer with an affordable system that actually meets or adapted to their needs. Additionally, the IP-based architecture enables you to share information with the ground seamlessly. I will show it in one of the next slides that we can actually remote control all the operation and actually extend the number of operators without any limitation. And everything, both voice and data is IP-based, so it's very easily being transferred to all assets. For example, we can use the SATCOM or the line of sight to exchange voice, etc. As I mentioned, interoperability is a key issue. Each user, in the case of India, is very clear. It's not following the traditional US or NATO links. They are using a much more modern approach. And we are trying to actually provide a solution for this. We have very high capacity line of sight link, SATCOM, 9 lines of sight link. We can ensure interoperability with both Air Force and Navy by using different waveform. We are naturally using software radio, software-defined radio, which can run any type of waveform that is required for the different user. Naturally, the end-to-end solution have a ground terminal and shipment terminal. Just an example for in-flight processing that was not available 10 or 20 years ago is ISA classification. So during flight, you have all the information available in real time. You can identify the asset. You can use correlate it with AES, for example. And the bottom line is that in real time, the operator can control the environment. One of the major challenges is the extreme number of functions that the operator have to manage, and if you can see, a human being cannot handle all of this capability manually. So actually the solution is a high level of automation. This is a trend that we have followed for the last 20 years. We believe in minimal manual control of the system. A very, very user-friendly and very advanced HMI that reduce the operator workload, and this is done by using, for example, window-based HMI. It means that the operator does not need 1 or 2 months of training. He knows it from the age of 5 or 6 when he uses a computer at home. I see that you agree. So it's very easily. Some of our visitors, especially even very distinguished guests, take 5 or 10 minutes to sit with this operator workstation and operate it without any training. The versatility. It's a multi-role OWS that can do everything, and you can just fine-tuning to the specific mission. And we are using Offboard OWS. One of the key elements is as I mentioned, a very powerful cost-based.
Time.
Okay, 2 more slides. Okay, and actually the key, as I mentioned, it's actually a tool for the operator to make the decision and action. All the sensors are fully automated. As I mentioned, the Offboard OWS is a very powerful tool. If you use broadband line of sight, you can have as much operator on a ground facility or a shipment facility that actually expand the number of operators. A summary. First, the choice of platform. It is usually a customer decision. We in ELTA are being able to provide all the range of platform, starting with the very small turboprop up to the high-level business jet. And as you can see, there are many missions that are done both on turboprop or business jet. To conclude my presentation, if we see the trends and the way that we respond to this trend, customer need for multi-mission, multi-sensor, and multi-role system. I don't think that anyone will buy the Motorola from the 90s. I think this is the case for the special mission. I see that most of the RFPs that we received are for very, very extensive mission suite and very extensive operational use. We use latest technology that enable us more system, more mission, less operator, and this is all of this can be done on a relatively small, like business jet or turboprop commercial aircraft. In-flight processing, a very capable tool. Most of these issues are relatively classified, but I think that you can understand that by the in-flight processing gives you a huge tool for complete your mission. Interoperability is a key factor for every customer, and use an IP-based architecture, which we are doing for the last 15 years, is something that enables us to tailor solution. And selection of platform, clearly a user decision, which we are able to accommodate. Thank you for your time.
Thank you very much, sir. I think we will have the discussions with them, but I see quite a lot of input for CAPS to prepare the next proposal.